Hey, good morning, guys. Um, Looks like right now we have Carter, Alex, and Morgan. Tim texted me. I think Tim. I'm not sure about Colton, whether he'll be here or not. Not sure about Ian either. So, but glad you guys are here. Hope you're all doing well um, in this journey. So, um, let's just go ahead and jump into this. Which is 26 homework. Let's check 26 homework real quick. So, are there any specific questions over 26 or problems you'd like to see me work over 26? Cool, yeah, no worries, Carter. Hey, Ben, how's it going, man? So, any questions at all over the homework? Any specific questions you want to see me work? Okay. So, Morgan says on number 7, she says this has two expressions right here, and she's wanting to know what would. Oh, sorry here. She wants to know which one is you, which is a good question. So how do we know which one is you? Well, here's the thing: either one of them can be you. You can make you whatever you want over here. You just have to be able to um, eliminate basically the other one and the dx from the du here. Okay, so I'm going to say majority of the time it's probably going to be the one with the power. Now again, of course, you're going to go find another problem that has a power, and then you're going to be like, well, which one then? And you just got to sometimes you got to try both of them to see which one would work. Not majority of the time. Maybe like 20% of the time you may have to look to see which one's better or whatever. But most of the time it's going to be the one with the higher power. But if I went over here and did this right here and said x to the negative 2. So for instance, I would go with that one just naturally. It's the first one. But if, let me grab a pen. So let's say that we make the u the other one. So u equals 1 over x squared. And we did low times the derivative of the high minus high times the derivative of the low. All over low, which would be x to the fourth. That cancels. That's negative 2x over x to the fourth. So notice here, Morgan, this right here would be my du would basically be that. Well, and that can simplify to negative 2 over x cubed. Okay? So I would somehow have to get this right here. Okay? I would have to get this to that right there. I would have to multiply it by something, multiply this right here by something to get it to meet that in order to take out this and the dx in order to make du. Because notice, so when we use 1 plus 1 over x as our u, and we took the derivative of that, we got negative 1 over x squared. So that was convenient because this is going to be my u, and I have the problem already gave me 1 over x squared dx. So only thing I needed was a negative on this side, so I'd multiply this side by -1, and then I multiply that side by the reciprocal of -1, which is also -1. So which one do you put as u? You should see it. You may have to just do the derivative of both of them to kind of see it, but you don't want to. You have to multiply this times something to get 1 plus 1 over x cubed. And to me, that would be a nightmare. And then keep in mind that you can only multiply. You can only multiply by a constant, so then that would kind of take that out as well. You couldn't multiply both sides because you could say, well, just divide that by -2 over x cubed, but you can't multiply all this times both sides because you can only multiply integral by a constant in this setting. Does that clarify that? Did I butcher that enough for you, Morgan? Okay, cool. All right, next question. Any other questions before we just kind of go? I'll go through and give you all the answers. Sorry, I didn't see your comment 4 minutes earlier, or I would have shut up, Morgan. I'm sorry. All right, give me a thumbs up if you're ready to just go through the answers of the rest of the homework. Give me a thumbs up if you're good to just go through the answers. All right, Ben's good, Carter's good, Alex is good, Ian's good, Morgan's good. Okay, so number 1 would be 2 times the quantity of x minus 2 raised to the 3/2 over 3 plus c. If you have a question, just type it in the chat box, and I'll kind of keep an eye on that just to make sure we're good there. Number 2 is negative quantity of 3 minus 2x raised to the 9th over 18 plus c. Number 3 is -4 times the quantity of 50 minus x squared raised to the 3 over 2 over 3 plus c. Number 4, the quantity of 6x plus 1 raised to the 4/3 over 8 plus c. Number 5, the quantity of 4x squared plus 5 raised to the 8th over 64 plus c. 6, 4 times the quantity of 3x cubed minus 4 raised to the 1/2 over a, or excuse me, 9, sorry, over 9 plus c. Chick-fil-A just sent me a thing that said you earned 20% more points in April. That's how I save lives, even though I'm not in the classroom. Number 7, negative times the quantity of 1 plus 1 over x raised to the 4th over 4 plus c. Number 8, x. So Alex said number 6. Shouldn't it be to the 3/2? Yes, to the 3/2. Thank you. I have it right here, 3/2, but I guess when I copied it over, I didn't. Thank you so much, Alex and Carter. All right. Hey, that shows me you guys did it, so that makes me feel a little bit better. Because really, we're working on the honor system here. There's no, obviously, I mean, I could make you scan it and turn it into me, but again, we're not, you guys aren't in kindergarten. So here, the quantity of x to the 4/3 plus 5 to the 9th over 12 plus c. Any questions? Give me thumbs up on the first page. Give me thumbs up if you're good. Questions if you have a question. All right, backside. Number 9. -1 over 8 times the quantity of 8x minus 1 plus c. Number 10. -20 over 9 times the square root of 4 minus 3x over 5. You could have kept that raised to the 1/2 as well. Either one works, plus c. For number 9, Carter said, can you explain why it's not over -8? So Carter, 8x, so we got u to the -1 here, and then so we plugged in u, but then you never want to keep an answer with a negative exponent. So flip that down. You with me? Flip that down. And then we just I just moved the negative to the numerator. So then the 8 stays in the denominator with the 8x minus 1. And then the -1 is just in the numerator now. Does that make sense, Carter? Oh, yeah. If you have the negative down here, you're completely fine. Remember that, like, and this is just an example, but like negative, let me get a piece of paper. Again, -1 over 2 is equal to 1 over -2, which is equal to -1/2. All three of these equal each other. They're all negative. Okay? So no matter where that negative is, you're good. And I just use 1/2 as an example. All right? Number 10, -20 over 9 times the square root of 4 minus 3x over 5 plus c. Or like I said, that could still be raised to the 1/2. Number 11, the quantity of x squared plus 10x plus 4 raised to the 3/2 plus c. Okay? All right. From there, number 12 would be negative radical x squared minus 16x minus pi plus c. Okay? 13, negative cosine of 5x over 5 plus c. Number 4, 2 sine of 2 plus 2x, or 2 plus 2 over x plus c. Let me make sure I'm showing you my u there. 15, 1/2, or no, sorry, going down here. Tangent of 8x over 16 plus c. Okay. So, and then 16. 16 was another kind of good example. We actually saw one of these on the homework, or excuse me, in the classwork. There it is, actually. Number 16 and number 15 here. This is number 15 from the classwork. These are very similar, but notice here we used u as 10x, right? And then we got the derivative of 10, and then we got it to 10x. And when we got here, tangent u of secant u, that is an antiderivative of just secant. So I started the same path on this. I said sine u and cosine u, but the issue is that's not an antiderivative. We don't have that on our chart as an antiderivative for anything. And there is no product rule. I said power, but I meant product rule. There is no product rule, so I can't say because we're not taking a derivative. Product rule is derivatives. We're taking the antiderivative. So then that kind of triggered me to say, okay, I got to change what my u is going to be. And keep in mind, I need to eliminate something. Well, I know that cosine is the derivative of sine, and there's a cosine, so that's when I just made sine of 4x. I just made this sine of 4x my u. So when I did that, I took the derivative. I got 4 of cosine of 4x. So then I knew I had a cosine of 4x dx. I just need to multiply this side by 4 and this side by 1/4. So this kind of is a separation. This is my new problem that I started. So I knew that. So I multiplied this side by 4, that side by 1/4, and then I simplified it from there. 4 cosine 4x dx is just du, and then sine 4x is my u, so I just put u there. Then I go to u squared over 2, and that takes me to sine squared of 4x over 8 plus c. Now, some of you may be saying, well, isn't the derivative of cosine negative sine? So couldn't I go that way? And you could. And if you did go that way, you would have got this answer right here. Negative cosine squared 4x over 8 plus c. Basically the same thing, but it's negative because obviously the derivative of sine, or excuse me, the derivative of that cosine would be negative sine. Yeah. So that one, just sometimes, like we said, sometimes you gotta get a little creative with it. Okay, just get creative with it. Again, you're just trying to eliminate stuff. All right, give me thumbs up on the second page. Give me thumbs up if you're good on the second page. Cool. All right, last page, which would be this one. 17. 17 would be negative cosine to the to the fourth x, or cosine x to the fourth. Either one's fine. Over 4 plus c. Number 18 would be tangent squared of 2x over 4 plus c. And it's okay if you said tangent 2x squared on the outside. That would be fine as well. 19 would be negative cosine of 6x raised to the 3/2 over 9 plus c. 20 cosine of 2x over 2 minus cosine x plus c. I did this first and then just put that on the end down there. So I took care of that, and then I put that, I just moved that to the end. 21, this is where we're starting to get du and dx to be the same thing, okay? And here you should have got 2/5 times the quantity of x minus 2 to the 5/2 plus 8 over 3 x minus 2 to the 3/2 plus c. Alex said I got something different for 20. What'd you get, Alex? If you can somehow type it in. Use parentheses and just type it into us. Okay, Alex, unfortunately, that would not work. Sine of 2x and sine of x plus sine x is not the same thing. So sine of 2x and sine of x plus x is not the same thing. You could imagine putting something in there for x, and it would be different. So give me 1 second while I type this out. So right here, just to explain, good idea, good kind of approach here, but just to kind of explain this. So sine of 2x, so let's, and I put my calculator here in degree mode just because I think you all would probably be able to see this pretty good. But sine of 2 times 30 degrees, which would be sine of 60, would be negative 0.3. And sine of 30 plus sine of 30 would be negative 1.97. So that kind of shows it's not the same. You could also just do like sine of 2x and then sine x plus sine x. And you kind of see they're not the same. So now 2 sine x would be the same, but not sine of 2x. That's your angle, which is a little bit different. All right. So that's the way I would work that. All right. Moving right along. Let me make sure I didn't miss anything while I was explaining that. Okay, cool. So 21, I think I said it, but 2/5 times the quantity of x minus 2 raised to the 5/2 plus 8 over 3 times the quantity of x minus 2 to the 3/2 plus c. 22, 3/7 times the quantity of x plus 1 raised to the 7/3 minus 3/4 times the quantity of x plus 1 raised to the 4/3 plus c. Okay, going down to the last two. Last 23, 2/5 times the quantity of x minus 4 raised to the 5 halves plus 16 over 3 times the quantity of x minus 4 raised to the 3 halves plus 32x minus 4 to the 1 half plus c. All right, and the last one threw a little bit of a curveball at us, all right? Because our derivative, notice on these three, du is dx, du is dx, du is dx, so you could easily replace. But number 24, notice that du was not equal to dx, it's equal to 2dx. So in order to replace what x is, which is u plus 1 over 2, I would have to add a 2 to the dx, which would mean multiplying this side by 1/2. So I threw it for a little bit of curveball. I don't know if any of you guys caught that or not. But obviously here we just can't multiply by the x. So within this, I kind of made a mistake there because I kept going. I was like, oh no, this is not going to work out. So then once you put the 2 there with the dx, now that's equal to du, but you had to balance the integral. So that would have to be 1/2 over here. So then you just plug u plus 1 over 2 into all your x's. And it comes out to be this right here, u plus 1 and u to the negative 1/2. You then distribute, takes you here. You then do the integral. And notice, this is another different part. Normally, we're used to just saying 1/2 times all of that because everything we've done, normally when you multiply, like for instance, like number 18, it's just 1/2 times this. And it's just negative 1/6 right here times all of this. But here, this is a binomial down here, which is something we hadn't seen. I don't even know if we saw it on the notes. So at the end, you just can't do it to the 1. You'd have to do it to both. And then that would take you to 1/3 times the quantity of 2x minus 1 raised to the 3 halves minus the quantity of 2x minus 1 raised to the 1/2 plus c. All right. Any other questions? Again, you can always go back and record it. I need to scan all this into Canvas just in case you want to go see it. So I'll try to do that sometime today or tomorrow in order for you to kind of see any answers or anything like that. I'll try to do that. Any other questions? If you don't have any questions, give me a thumbs up that you're ready to move on. Morgan's good. Alex is good. Ian's ready. Ben's ready. Carter's Gucci. Okay. Looking at number 27 classwork. Give me a thumbs up that you got that out. Give me a thumbs up that you have that out. Morgan's good. Carter's ready. Ian's good. Got it. Ben. All right, we're all here. Okay, cool. So, let me bring my face into this now. I don't have my green screen up. You can just see my wife's lovely floral blinds. Let me get a little bit of light on myself. My goodness. So, just looking at this, here's what I'm going to do. We are not going to take these notes today. Okay, we are not going to do 27 classwork. After thinking about it, we've been going pretty hard for the past 3 weeks. And my thought was, if we do the classwork now, then when are you going to do the homework? Probably a week and a half later, way after spring break, the Monday or probably the Tuesday that we're going to get back on the live lecture and check the homework. Okay? So if it's fine with you guys, we are going to call it a day today and call it tomorrow you have off. And then you can enjoy your spring break. People constantly text me and say, hey, man, I bet you're bored to tears. And it's just like, no, I am not bored to tears. I am not bored to tears. We're still on the grind in the education world. So obviously we don't make an impact as much as, the doctors, the nurses, the first responders or anything like that. But teachers, we are still on the grind, even though people think we do nothing at all. So this has been a grind. So it's just like, man, you know what? I was afraid that you would do the notes now and then you would just get totally confused. So we will jump back on this on Tuesday. Okay? The Tuesday after spring break, I will send you your schedule. Probably the Sunday after spring break, I'll send you the schedule for that week. But just plan to be here on Tuesdays and Thursdays. Does Tuesday and Thursdays at 1, does that work for you guys? Because they're wanting us to get into more of a where every class is the same time every day. Does that work for you guys? Give me a thumbs up or, yeah, that's cool with me. I need to take a phone call real quick. 1 second. All right, sorry about that, guys. It was my bank calling me, and the last time the bank called me, they said that my account had been hacked. Okay. All right, so I don't remember what I was saying, but hey, have a good spring break, good weekend. Hey, something, and I think that you all were saying, yeah, that's 1 o'clock is good for most of you guys. Okay, yeah. So we'll keep Tuesdays and Thursdays at 1 p.m. We'll just do that for those remaining 3 weeks until we go back to school. I'm speaking that in faith. So the remaining 3 weeks until we go back to school, we will just meet on Tuesdays and Thursdays, okay? Tuesdays and Thursdays. Now, there may not, after maybe 2 weeks, I may have to reach out to you guys and give you your binders for your AP test. Again, there's a meeting today, happening today with AP, and they're doing a webinar, and they're sending out all kinds of information about what this test actually looks like, so that'll give me a little bit more understanding of that. In addition to that, I have more notes for you. So here's what I'm going to have you do. I'm going to send you an email, okay? And on that same Tuesday, I think it's the 14th that we meet, you will need to bring all your homework to the school, okay? There'll be a drop-off box for you to put it in. It'll say Mr. Alpach AP Calculus. You drop it in there. In addition to that, I will have the next set of printed notes and homework for you. Just so you don't have to print off all that work at your house. You can just go by the school and get it. But all this homework that we've done thus far, and guys, for you it's pretty simple. You just got to copy down what I sent on the what I've done on the videos. So for me, for you, I think it'd be pretty simple from here. So just a kind of a guideline. All homework is due Tuesday, April 14th. You're going to have to take it to the school, put it in, just maybe put it in a box or something there around the front lobby. You'll see, it'll make sense, okay? And then you'll pick up another packet, and then we'll kind of go from there. And hopefully we'll have more information then for about the AP test. Any other questions of me? I'm not seeing anything. Hey, one more thing. On Fridays of those week, I'm going to set a time for us to Zoom. Okay? For us to set up a Zoom meeting just so we can talk, just to kind of keep our normal activity going. We can talk about anything. We can talk about politics. We can talk about coronavirus. We're going to eliminate all the math on Friday. But on Friday at like a certain time, probably 1 o'clock would probably be good for me. It may need to be a little bit different depending on my other classes. But 5 o'clock is probably what we'll do. Or not 5 o'clock, excuse me. 1 o'clock is what we'll do. And we can set and we can kind of talk about just how everything's going, just to get some more normalcy back to us. We can talk about books. We can talk about anything you guys want to talk, the death penalty, anything you guys want to talk about, we can talk about there. I enjoy talking to you guys, but that'll give you the ability to speak, and we'll be able to see each other as well. So does that sound good? Give me a thumbs up for that. Zoom in on Friday. And that's once we get back from spring break. All right. Hey, if you guys don't have any other questions of me, feel free to go ahead and log off. You guys have a good spring break. Read some books over the break. I encourage you to pick up a book. If you need a book, I'll give you my address, and you can come to my mailbox, and I can give you some book. I can put some books in the mailbox for you to read over the break. If you need some books, hit me up. I'd be glad to. I can give you some books that are good. I've been sending books to people for a little bit now. So you guys have a good break. I appreciate it. You all have a good one as well. If you have any questions, I'll stay on for a few more minutes. But if not, you guys have a good break. Love you guys. See you soon, okay? See you soon.